Hi everyone, thank you to my channel. If this is your first video, my name is Dr. Christina Sweeney Hillesheim, and my channel is on just discussing topics that are related to religion and science. And so this is my ninth talk. Most of my talks are standalone. I will do a little review at the beginning of this talk, but I do suggest if you haven't watched my previous talk on the age of the universe, that might help you a little bit. So if you start watching this talk and you go, I'm a little not following, I'm a little lost, then maybe go back and watch the last talk just because I kind of explain where I get the million transition of the time that I will be talking about in this talk. That's where I get it from, is the last talk. So all the other talks I would say are pretty standalone, but this one it might be helpful to go to the last one. But you're welcome to start the talk, and if you are following along, then awesome, no problem. All right, so this talk is on the 6 days of Genesis. And so previously we talked about how do we understand the age of the universe and billions of years old, and then how do we relate that to the Bible, which says that everything was done in 6 days. And so our last talk, we kind of talked about how do we actually relate that? And how do we deal with those two different kind of perspectives on time? And so now we're going to go a little deeper and look at the 6 days of Genesis and what happens on each one of those days from a scientific perspective and from a biblical perspective. And so this is going to be kind of the table that we're going to kind of dissect and get into. But you might notice here on the first column on the left side, we have day one, 24 hours, day two, 24 hours, etc. But in the second column, you might see that the time is 8, 4, 2, and it kind of decreases down. And so you might be wondering, well, why does each day have kind of different times associated with it? And that's what we're going to kind of dive in with this talk. I won't go back to this table and I'll explain it more in depth. So just a review from the last talk. So remember when we talked about that where you're viewing time is relative. It depends on where you are located. Depends on where you're located to your light source and also to the gravity of the location that you're at. And so remember we talked about how time on Earth is different than time on the moon versus time is different, on Jupiter or another planet. But, however, when we're talking about the 6 days of Genesis, this is before Earth was even created. If we're talking at the very beginning of those 6 days, there was nothing. So we can't talk about time being based on Earth. It's not Earth-based time because Earth didn't exist. So remember what we did is we translated Earth-based time to cosmic time and kind of space-time. And so we did the conversion of space-time into Earth time. And that's how we did the conversion of the universe's age as well. So remember that whenever the light is going to be coming from different areas, it's going to be stretched different. And so because it's going to be stretched, that affects our time. If it's stretched, then time is going to be slowing down, and that's going to affect how long something takes. And so the relationship between Earth time and space time that we found, that conversion was a million factor. So if we wanted to say, well, how much faster, how much slower does it go? Oh, it's 2 times faster or 3 times faster. Like time on that planet goes faster or that time on that planet goes slower. So when we were comparing Earth time to space time, we noticed that it was a million times difference between our local perception of time and the Genesis cosmic time. And so remember when we did that math, we found that the age of the universe, those billions years old, when we converted it into Earth-based time, we found that it was into cosmic time, my apologies. We found that it was 6 days. And so it actually matches perfectly. And so also just to refresh, this came from the stretching of light waves. And when we talk about light waves, we're not just talking about visible light. We're talking about all the spectrums of electromagnetic radiation. So these are microwaves, X-rays, and gamma rays. So all types of radiation or light sources. So just a refresher, how was this calculated? So this was calculated from the cosmic microwave background radiation. So remember that when the Big Bang happened, the Big Bang produced a lot of energy. And so there was one type of energy that would have been present at the beginning of the Big Bang. And so that radiation started, but then remember, the Big Bang happened, and then everything started to cool off, but there was remnants of that radiation that was still left. And that remnants of that radiation is still present now. So the radiation that was present then is present now. And this is that background radiation. We don't see it, but we were able to find it through different experiments, different things that were happening, we're able to discover this background microwave radiation. And if you'd like more information on that, you can watch my lecture, my talk on the Big Bang, and it talks about how the background microwave radiation was found. So, since this was the only radiation that was present since the Big Bang, then this is kind of the radiation that we could use as our kind of our baseline. And so it's characterized as the temperature of a black body that would emit the same radiation pattern. So if it's a higher temperature, it would have a higher frequency of radiation. So what we can do is instead of talking about frequencies, we can actually just convert it into temperatures. And it just gives us a better way of kind of talking about that radiation in terms of temperatures instead of frequencies. So the temperature of today's microwave background radiation is 2.73 Kelvin or a negative 270 Celsius. And so the way you can think about this is the radiation, the frequency, the temperature of the kind of the blackness of space. One is the temperature of space. In a sense, this is what this is. And so we can relate the temperature that we have now of the radiation that was left over to the temperature that occurred at the Big Bang, which was a million times hotter. So it's really hot, and then after it kind of calms down, you have radiation. You can kind of think this is similar to an atomic bomb. There's a moment that's really hot, but then there's always that radiation that still exists. So even now, if you go to Chernobyl, there's still some radiation that's kind of left in the environment. So kind of the same idea, but on a much bigger scale. So what does that mean? So remember we talked about that as the universe expanded, so after the Big Bang, the universe starts to expand. So now its size or its scale and its temperature is also going to be affected, and therefore its clock. Okay, so as it expands, its size and temperature is going to affect its clock. And so as it's expanding and as its temperature is starting to cool down and it's going to start to become more similar to what our current universe is. And so the duration of each successive 24-hour day is actually encompassing a span of time. So originally when we talked about it, we said, okay, you've got the age of the universe, billions of years old, and these 6 24-hour days. So you might say, okay, so the duration of these encompasses this entire amount of time. So the duration of each successive 24-hour day encompasses the span of time over the entire universe, the beginning of the age of the universe. However, as the universe is expanding, that clock is becoming more similar to our clock. So at the beginning of the age of the universe, at the beginning of the Big Bang, the clock is going to look much different, million upon million times different than Earth's space clock. But as the universe expands, that clock changes. So each doubling in size, as the universe doubles in size, the clock is going to slow down. And it's going to slow down by a factor of 2. So as the universe is expanding, the cosmic clock is going to slow down by 2. And as it continues to expand, it continues to slow down until it gets closer to our clock on Earth. So how do we actually figure out this slowing down and how much it's slowing down? So you might think, okay, so if the universe is expanding and as it expands, the clock slows down, that it's just, oh, I just divide it by two every single time. But it doesn't slow down just by a division of two excessively. Each successive Genesis day is actually decreased or slowed down by an exponential amount. So each successive Genesis day exponentially represents fewer years as perceived from our earthly vantage. So what that means is we can't just say, okay, day one was this amount of time, divide by two, divide by two, divide by two. The relationship there is actually an exponential relationship. And this change in time is dependent on base that occurs throughout the universe. And it's the natural log. So the way that our clock, as the universe is expanding, as the clock is slowing down, it's actually based on the exponential spiral. And so I'll show you some examples of this exponential spiral. But what it says is that each of the spiral's successive swirls is wider. So it's not that it has the exact same width as it goes out. But it's not just random. It's not like it just gets bigger and bigger and bigger randomly, but it is actually a fixed factor of how much it is going to widen. And so this is going to represent that relationship between Genesis time and Earth's time as the universe expanded out from its point of creation of the Big Bang. Then as it expands, that relationship of the time, even though we know the difference of a million fold, how much it's decreasing, how much it's slowing down is based on this exponential factor. And so, like I said, the exponential spiral we've seen throughout nature. Here in the top left is a nautilus seashell, and you can see, excuse me, you can see that curve in the seashell. So at the center, and as it spirals outward, it starts to get thicker and thicker and thicker each spiral. In the middle left side is the ammonite shell, ammonite fossil, and you can also see that each ring in the spiral is getting bigger and bigger as it goes out. We also see this in the distribution of seeds on a sunflower and the spread of stars in a spiral galaxy, like our very own Milky Way. So our Milky Way is a spiral galaxy, like we talked about in a previous lecture. And as we can see, that the distance kind of gets bigger and bigger as it spirals out. So this exponential spiral, this mathematical idea, is actually seen throughout our universe. Now, it's not just an idea, we actually have an equation for it. So the exponential spiral was kind of formulated by Jacob Bernoulli. And he's the one that formulated the shape of this curve in kind of a mathematical terms. And so first we can think about it in polar coordinates. And so here's the equation for the exponential spiral, and you can also see it in a picture form on the right. So R equals E, which is the natural log, raised to AH. So R is going to be the distance from the XY intersection on the graph if the origin is at 0. A is a constant, and H is the angle between the line 0R and the x-axis. And as H increases in value, the point R is going to spiral out further from the origin. And so we get an even wider and wider spiral. Now, if the exponent is negative, we have a negative AH, then what happens is the point R is going to spiral in toward the origin and kind of in a swirling vortex pattern. And it actually just keeps on going. It has no end. It actually never reaches the origin. It just keeps kind of going closer and closer and closer and closer and closer. Now, polar coordinates are helpful from a 3D kind of perspective, but it's a little easier for us to kind of think of things, especially since we're thinking time, and time is a linear, starts here and it's progressing in one direction, time. We want to think about it more in Cartesian coordinates. So we can actually take that exponential spiral formula and we can convert it into a linear XY Cartesian coordinate formula. And so this is the formula that we have here. So A is equal to A naught, and then E, natural log, is raised to the negative LT. And so A here is the Earth time, and this is the number of current Earth days contained within one Genesis day at any given any given instant during the 6 day period. So this is saying, if we're talking about, one day and then cosmic time. So if we're trying to compare cosmic time to Earth time, and we're trying to do that comparison. A naught is the ratio of that cosmic microwave background radiation, that frequency or the temperature, at the threshold energy of protons. So that is going to be the ratio of the threshold energy. So the point where we do not create any more protons, neutrons, and electrons, to the current value of that cosmic microwave background radiation, frequency or temperature. So it's the ratio of those two values. L is the natural log of 2 divided by the half period, and the half period in our case is going to be 1 Genesis day. And T is the time in Genesis days, and it's going to be from 0, 1, 2, 3, 4, 5, and 6, because we're looking at the 6 days of Genesis. And then here you can kind of see that exponential spiral in the Cartesian graph on the right. So how can we use this to kind of relate our Genesis, our cosmic time of Genesis, to Earth time? So we have our exponential spiral formula in Cartesian coordinates. And this is better, like I said, because we want to see that relationship between Earth and cosmic time in a linear fashion, because it's progressing, or we're talking about it in a backward sense. So either way, whenever we're thinking of time, it's only in one way, one direction. It's not polar coordinates. We're not talking about 3D time. Interestingly, this equation also is the same equation that's used to calculate the exponential rates of decay of radioactive atoms. So if we're looking at things, decreasing in radioactivity, it's another way. So kind of relates time and energy. Now, if we want to get the duration of each Genesis day, as viewed from our perspective of time, we need to solve the following equation for each of the 6 days. So we need to go in and we say, okay, let's put in 0 for time. Let's put in 1, 2, 3, 4, 5, and 6. And when we go through and we do all this and we solve, we want to solve for A. And then that's the way that we're going to be able to get the number that was in that chart regarding how much time had passed for each one of those days of Genesis. So this is how we were able to fill out that chart that I showed you at the beginning. And so this is the equation that we just used. We plug it in, and then our days are going, the answer will be in days, converted to years, and then we get this table. And so this is the table that we're able to get. And so here, if you look at it, we've got our 6 days in our first column here of Genesis, each one of them as a 24-hour day. But remember, we said that we did the last talk related these 6 24-hour days to the billions of years. And we said that that's how we were able to convert, using that cosmic microwave background radiation, the age of the universe from cosmic time to Earth time. And when we did that, that's how we got the 6 24-hour days. But that's really like an average. Take all this time, convert it to all of this time. But then if we want to look at each one of these days specifically, then we have to look at what's happening in the environment of the universe at each of those days. And that's why I was saying, as the universe is expanding, it's not just take the billion years that we have, divided by 6, and that's how much you have for each day. That's not how it works. That we have to use that exponential idea of that spiral and look at it. So as you can see here, the beginning is going to have a lot more. It's a thicker spiral. And as we go down, we're going to decrease. And this is in an exponential decrease. So as the universe is expanding, then our time is slowing down and we're starting to kind of get more similar time. And then that's why our amount of time is also decreasing because the universe is expanding. And it expanded a lot at the beginning. And as the universe continues, it's still expanding, but it's not expanding as quickly as it was right after the Big Bang. So now let's actually look. If I say day one was this many billions of years, day two, etc., how does that match with both what the Bible says happened on each day and what science says happens on each day? So let's break down each of these 6 days. So day one, this would be the start of the day, so years before present, and the end of the day, this many years before present. And that is about our 8. So if you look here, this is going to be our 8 billion years, 4, and then 2. So you have 8 billion years, 4, and then 2. In day one, in the column here, in the table, in the second to right column, I have what's the Bible's description. So what does the Bible say in Genesis happened in day one? So in day one, the creation of the universe, light separates from dark. And then I have the scientific description. Okay, so the Big Bang marks the creation of the universe. Light literally breaks free as electrons bond to atomic nuclei and galaxies start to form. And now we're going to go through each one of these days, but this is just a summary so that you can kind of see a comparison of what happens from both perspectives. Day two, the heavenly firmaments form. From the biblical perspective, from scientific perspective, the disk of the Milky Way forms, which is that center part of the Milky Way. And the sun, which is the main sequence star, forms. Day three, oceans and dry land appear. The first life, plants appear. The first life and plants appear. Scientific description, the earth has cooled and large bodies of water appear about 3.8 billion years ago, followed almost immediately by the first forms of life, bacteria and photosynthetic algae. Let's go through each one of these, and then we'll have a chart for the last 3 days. So Genesis day one. So from 15.75 to 7.75 billion years before present. And so what starts day one? So the beginning of day one starts with the Big Bang. So we know that the universe has a beginning. If you aren't so sure about that, you can watch my Big Bang lecture, and you can also watch my Kalam cosmological lecture that talks about the universe having a beginning. In Genesis 1:2, it says a one-time phenomenon described as the Spirit of God hovering over the universe. So, what would we kind of think of in relation to that in science? And so, there is actually something that was required to start the making of the universe. Okay. And so, what happens is we have the Big Bang, but then what also happens is inflation. And so, inflation is the sudden and brief expansion in the universe immediately following the Big Bang. So, you have the Big Bang, you have a lot of energy that's released, but then you need to start that expansion, that inflation of the universe. And so this physics explanation of kind of something hovering over and kind of starting the universe is very similar to what we read in Genesis 1:2. Genesis day 2 is from 7.75 to 3.75 billion years before present. And what kicks off Genesis day 2 is the shaping of the galactic disk of the Milky Way. So if you look at the right picture here on your screen of our Milky Way galaxy, kind of that, if you think about it like an egg, I guess, kind of the yolk in the middle, that is our galactic disk. And so from Genesis, it talks about the heavenly firmament took shape. And so at this point, our galactic disk is formed. And then as it continues during these billions of years, it's almost totally composed of stars in our main spiral disk here. So stars are starting to form and fill up that spiral disk. At about 4.6 billion years, our sun is formed. And also some of the oldest stars of the Milky Way are found. and they're found in these globular clusters, so big clusters of a bunch of stars. And they're found right outside of that spiral disk. So you get the spiral disk formed, you get stars within the spiral disk, and then you start to get stars that are formed right outside the spiral disk. And they're really difficult to see, and they're barely visible without, a very highly powered telescope. So on to day 3. So Genesis day 3 goes from 3.75 to 1.75 billion years before present. And what kind of kicks off this day is that around 3.8 billion years was the close of an era, during which Earth was bombarded by a rain of meteors. And these meteors were so intense that the start of any life wouldn't have been probable, or even if there were life, the survival of any life would be highly improbable. And so this is kind of like the wiping out of anything that existed and just kind of the beginning of that transition period of kind of having radiation and having a lot of energy and being able kind of to transition into a more habitable planet. And so at this time, the first liquid water on Earth as the oceans and the dry land appear. And then we start to have the first plant life. And so the first plant life that we have here are going to be kind of like bacteria and algae. And then in time that will follow, we'll have land plants and flowering plants. So that's Genesis day 3. So now let's look at the continuation of our chart for days 4, 5, and 6. So here you can see in day 4, 1,750,000,000 years to 750 million. And then day 5 is only 500 million years, and then down to day 6. And the descriptions here, the Bible's description for day 4, the sun, moon, and stars become visible in heaven, invisible in the heavens. And the scientific description, Earth's atmosphere becomes transparent, and photosynthesis produces oxygen-rich atmosphere. Day 5, the first animal life swarms abundantly in waters, followed by reptiles and winged animals. So here we're going to see in the scientific record, the first multicellular animals, and waters swarm with animal life, having the basic body plans of all future animals, and winged insects appear. And then on day 6, we have land animals, mammals, and humankind. In the scientific record, we have a mass extinction that occurs destroys over 90% of life. Then land is repopulated with hominids and then humans. So let's go through each one of these days. So Genesis day 4, from 1.75 billion to 750 million years before present. And so during that time, the atmospheric concentration of photosynthetically produced oxygen rose to concentrations comparable with today's atmosphere. So if you remember in day 3, we start to get plant life. And one of the things about plants is they convert carbon dioxide into oxygen. And so as the plants have been there, and as they're doing their thing, doing photosynthesis, they're going to be able to produce oxygen. And over time, that oxygen levels are going to increase. And at this time in day 4 of Genesis, and they are comparable to today's atmosphere. But what also happens with this increase in oxygen is that our atmosphere is going to appear different. Instead of having this kind of foggy kind of view, as you might see kind of in the left picture here of Earth, it's going to become more clear. Also during this time, Earth is starting to cool down because as you remove CO2 from the environment, the Earth will actually cool off. That's one of our natural geological processes that is built into our system. And so as we remove CO2, the Earth will start to cool. And so that will also help with increasing that oxygen level and transitioning the atmosphere from a more translucent or foggy vision to being something more transparent. And this relates to Genesis 1, 14 through 19, where it says, the heavenly bodies became so clearly visible that they could be used for telling times and seasons. And so now we can actually see, because it's not so foggy, we'd be able to see the moon, other stars, the sun, and other planets. Okay, so day 5. This is from 750 to 250 million years before present. And this is when we're going to enter the Cambrian period. And in the Cambrian period, we have what's called the Cambrian explosion. And at this point in the fossil record, there's an explosive appearance of the first animal life. And this is the first multicellular organisms. And then around 530 million years, we have all the basic plans, all the body shapes of modern life is present. And then 360 million years ago, we have amphibians, reptiles, and winged insect life. And so in this period of time, we just have an explosion of life, different life, diversity of life, both from aquatic life and then smaller land life, insects, amphibians, and reptiles. And then day 6, which was from 250 million to 6,000 years before present. And the end of this day is it's ended at the time of Adam. So once human life, Homo sapiens, come onto the scene, that's the end of kind of our math, our timeline. The beginning of this day, between 90 to 95% of all marine life disappeared from the fossil record around 250 million years, and that sets the stage for flourishing of animal life on dry land. So marine life kind of dies away, and then we transition into having more land animals. And here on this day, we see hominids, the great apes, and we get orangutans, gorillas, chimpanzees, and then we get humans. And so that is kind of just a breakdown of what happens in each of those 6 days in relation to the scientific record. I know it's a little bit of a quick overview, but the idea here is just to kind of show you that what is said in the biblical record of happening on each day doesn't actually disagree with what happens in the scientific record. There is correlation there. And so just to give you something to think about. So thank you guys for coming to my talk. My next talk will transition a little bit away from thinking about things from a cosmic level and in the universe. And now we're going to start looking about things in a very more microscopic level. So we're actually going to start talking about more about evolution and how that process worked. Is it a process? And we're going to start looking at it from more of a microscopic level and then build up to human evolution. So I hope you watch my following talks. Here are some references for this talk that you are welcome to check out.